Utilizing the joint NASA-European Space Organization, ESA, and Canadian Space Office, CSA, James Webb Space Telescope, a gathering of researchers has found an assortment of never-before-seen highlights in Jupiter's upper climate. The elements were tracked down in the air district over the notorious extraordinary red spot, a high-pressure locale in Jupiter's environment that creates a monstrous anticyclonic tempest that has been noticeable to cosmologists beginning around 1831. Before the most recent perceptions of the district, researchers accepted the area was unexceptional in nature and facilitated no mind-boggling climatic designs or action. In any case, Webb has shown that the district is logically fascinating and is now furnishing researchers with additional understanding into the inward functions of Jupiter and its gigantic air. While it might appear to be simple, noticing Jupiter with bunches of detail utilizing immense telescopes like Webb and Hubble is troublesome. The sparkle from Jupiter's upper environment is feeble, contrasted with the shine from the planet's northern and southern polar locales, implying that noticeable light telescopes like Hubble and some ground-based telescopes make some harder memories noticing explicit designs inside the planet's upper air. Be that as it may, given Webb's aversion to infrared light, the telescope can notice the upper air without impedance from the planet's brilliant polar locales. Also, Webb's high-level designing and size implies that it might not just gather information on the upper environment at any point, yet do as such with remarkable detail. Jupiter's upper climate fills in as the limit between the planet's enormous attractive field and inward environment, and its construction is generally formed by the collaboration between the two areas. For instance, the upper environment, with some assistance from volcanic materials shot out by the Moon Io, delivers brilliant northern and southern lights. Nonetheless, nearer to the planet's equator, the barometrical design is to still up in the air by approaching daylight, and considering that Jupiter just gets 4% of the daylight that is gotten on the planet, researchers anticipated that this district would be less complicated than the more northern and southern locales of the upper climate. Nonetheless, this was basically a speculation by the researchers, as need might have arisen to decide the construction of the upper climate in tropical locales were not yet accessible. That was until the presentation of Webb in 2022. Webb originally noticed the central districts of the upper environment, explicitly a region situated over the incomparable red spot, in July 2022, utilizing the Close Infrared Spectrograph, NIR spec instrument's essential field unit abilities. The group of researchers' principal objective with the perceptions was to examine the area and decide whether the locale was dull, as had been recently suspected by researchers. At the point when Webb's perceptions and information were gotten back to the group, nonetheless, they were shocked to see that the whole district over the incomparable red spot has different perplexing designs and movement, including dim bends and brilliant spots. We thought this area, maybe gullibly, would truly exhaust. It is, as a matter of fact, similarly as fascinating as Aurora Borealis, while perhaps not all the more so. Jupiter never fails to astound, said lead creator Henrik Mellon of the College of Leicester in the assembled realm. A significant part of the light radiated from this locale is reflected daylight. In any case, a portion of the designs and action found in this space have all the earmarks of being modified by some component other than daylight. One manner by which you can change this design is by gravity waves, like waves crashing on an ocean side, making swells in the sand. These waves are created somewhere down in the violent lower environment, generally around the incomparable red spot, and they can go up in height, changing the construction and outflows of the upper climate, Mellon made sense of. Mellon et al. Make sense of in their review that these barometrical waves can at times be seen on the planet. Notwithstanding, the waves that happen on Earth are far more fragile than those that have been seen on Jupiter by Webb. The group intends to perform follow-up perceptions of these airwave examples to examine how the waves travel through Jupiter's upper environment. Moreover, understanding the wave examples will permit researchers to foster a comprehension of how much energy is held around here and how the designs found by Webb change after some time. Webb's most recent perceptions not just furthers comprehension, researchers might interpret the Jovian upper climate, however will likewise assist with figuring out mission arranging and future logical perceptions on ESA's Jupiter Cold Moon's Wayfarer, or JUICE, mission. JUICE is at Presses,